Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, today I'm going to talk about some very recent work that I'm working on. I'd love feedback and improvement suggestions. It touches on a bunch of different areas. It's something different. So some of you might have expertise in different parts of it. So the question is, we're all struggling with reading, especially as our devices get smaller. And when you think about it, the letters we use to read are these really ancient, thousands of years old letters that people were inscribing in stone and writing on papyrus and stuff. And those are the letters we use. If my kids were to ask me why we use them, it's because my parents used them and my parents' parents used them. Well, not really. They used a different language. But anyway, some old people use them, and that's what we're using now. And it seems to be really hard to change the letters you use. But you still might ask the question, is this optimal? Let's even say we're just still reading English. I'm communicating with someone else in English, but what not exactly font, how should I represent these letters? What script should I use? And especially as we're moving to watches and everything is getting smaller, we might want to try to pack a little more information on smaller screens while still being readable. Okay, can anyone here read this? What does it say? Very good. Microsoft Research Lab, India, right? So I was in India recently in this year, and it kind of inspired me a bit. One of the things, their beautiful script, this is Kannada, I believe, and I was visiting some people at Microsoft Research in India, and they gave me a tour and showed me the palm leaves. And the reason that the scripts in South India are so curvy is because when you write, they used to be written on a palm leaf. And when you write on a palm leaf, if you write straight, it tears the palm leaf. Okay, so there's a whole family of languages that have a script like that, and that's why it is, and that's why they write that way. And our alphabet has its own history, which is also very old, and we have our reasons for our letters. So that's why we read the letters the way we do. But you might consider alternate scripts. Of course, we have some cursive. We have shorthand. Nobody uses that anymore, really. But there's Braille. So there's a bunch of different alternate ways of writing the alphabet. There's actually a neat website that I encourage you to go to called Ambiguity, where people have been very creative in coming up with all kinds of alternate ways of writing English, mostly just hobbyists. But most of the ideas of presenting things that I've thought of have already been, and I'll talk about, have been presented by somebody here. The thing that they haven't done is they haven't really thought about optimizing using data. Okay, and it's important to optimize your script, otherwise it won't necessarily be any better than English, and nobody would, well, not nobody, but it would only be used for fun. Also worth mentioning, if you say, well, if I'm thinking of changing the letters, why not just change the language? Even better. And there have been people doing that, right? There's this language called Esperanto that many of you have heard of, and pretty cool. I mean, somebody got 100,000 people to learn this language, and learning a language is a hard thing. It's not just learning a new alphabet, it's learning all these new words. But on the other hand, somebody deciding, should I learn Esperanto or Chinese? If I learn Esperanto, I can talk to 100,000 people. If I learn Chinese, I can talk to, a billion people or whatever. So, so for this talk, I'm not going to think about that. It's a super interesting problem, but I'm just thinking, lowering expectations. Let's just think about how we present the letters A through Z, okay? All right, so I'll talk about the problem and what does it mean even to do well. It's not an easy thing to define. And to try to convince you basically, ask the question really, how much better could we do? Can we do 5% better? Can we do 300% better? Can we fit a lot more or just a little more? And I think that's really the crucial question behind this problem, okay? I'll talk about kind of a wacky script that I don't think anyone is going to say this is the greatest script ever. But it'll be good to think about, as an example of how you would optimize this script. So this script in particular is mapping, each letter is 3 dots tall, black or red or white. So there's 3 times 3 times 3. There's 27 options. One of them is all white, which is a space, and so that leaves 26 options. There are 26 letters in English. So it's a matter of what permutation do you give for each letter in English to each of these columns. So each letter is, again, just a column. I've written the English letter, the Latin letter on top, or on each of these words, so you can still read it. But the idea would be to phase that out and eventually sort of remove those letters so that you just read the shapes So this is, again, I'm not claiming this is the best script ever, anything like that. I'm just going to say, well, how would we go about optimizing this? And it has some of the features that you would have when you try to optimize any script. It has some interesting properties that each word here has a shape. If you ignore, don't read the white stuff, and just look at the red stuff, each word has a shape. Like U has this sort of C-like shape. So it's almost like a logography, like Chinese or something, where words have shapes. But on the other hand, if you don't recognize the shape of the word, you can break it down and read it one letter at a time. Whereas, say, take Chinese, if you don't recognize the shape of a word, go look it up in the dictionary. It's not that easy. So that'll be a fun example to go through. And you don't have to use colors, of course. I'm actually colorblind. I prefer using black and gray, but other people may prefer their own. And you can use whatever you want. And one thing, some of you might be thinking that I'm actually very ambitious, that I'm thinking that tomorrow you're going to go down to the cafe and you're going to have these new letters. It's not what I'm saying. I'm saying, just some small fraction of people who are interested can put this on their phone or on their browser or whatever. And if they're interested in learning this new way to read, they can do that. And if they like it more, if they can fit more information or whatever criteria they have, they may use it. So what are the goals that you might have from a different script? There's so many of them. And you kind of want to balance all of them. But the first thing to realize is not everyone has to use the same script. Because we have this new technology, you can have your phone translating essentially between you and everyone else. And you're seeing your letters in your way, but it's all English going back and forth, and nobody knows what font you're using, well, what representation you're using, what script. So what are the goals? So you, of course, want it to be readable. And that's very, very important. I've had many people tell me, oh, yes, I would like to be able to read without my reading glasses. And as I know, within the next 5, 10 years, I'm going to probably need reading glasses because my parents did at that age. So I would love to be able to read without reading glasses, so nobody knows how old I am. I would like to be able to read when things are small, of course. So what would be a good way to get that? Or pixelated is another problem if you don't have huge, awesome resolution on your device. A lot of reading is not about just linearly reading through text. It's scanning, right? You're scanning through your emails. You're scanning a web page. You're scanning your text messages or whatever. So that's very important. How quickly can you spot something when you're scanning? How quickly can you read in general, of course, is very important. And do you understand? All these things are very important. Can you learn it? Can somebody new learn these types of scripts? Also super important. And are they aesthetic? Nobody wants to look at something super ugly, which is why I definitely need to partner with some design people. Okay, but you get the idea, I hope. But a simple goal you might think of, there's so many different scenarios, and you kind of want to compromise between all these, but think about maybe a natural goal is, how much more information could we fit on a screen, say a phone screen or something, while still being readable, okay? Or equivalently, could we keep the same information and make it more readable? And I think it's neat to think about even when things are blurry. So it's nice to have delicate lines in a script. It's great. They're beautiful. And they can add clarity. But it'd be nice if it's also readable when things are a bit blurry. Because there are many times when things aren't right next to you. They're over there. There's food smudged on your screen. There's all kinds of reasons why things are blurry. And it should be learnable and beautiful. So that's a lot of things. I'm not going to present a solution to that. But in watching me try to do that, I hope maybe some of you will get inspired by this problem and see some of the obstacles and kind of interesting problems from a machine learning point of view that it raises. Okay, so there's a nice script here that I heard about from talking to many people. The first was an intern who's Korean, and they said, the Korean is great. And I said, really? And I was kind of suspicious, but then I talked to some linguists, and they're like, oh, you should look at Korean. Everyone keeps telling me about this Korean alphabet. So, and it's a neat story, too, because one day the king just said, look, my court, we've designed this new script, and we're switching. And, because in general, it's hard to switch languages. I mean, before computers, there was no point in switching your own script unless you wanted to do steganography, cryptography. I mean, you had to get other people to do it in order to read. And so the king just okay, we're switching. And they invented this very nice alphabet. Even the shapes of the letters reflect how your mouth is when you're pronouncing those sounds and things like that. It's very simple, and the simplicity of the language translates into making it easy to learn, and actually into other things, like it's easy to type. There's been other studies when someone has a stroke and they know Korean, afterwards they're better off reading Korean than if it was English. Somehow it's deeper embedded in there. Does anyone here read Korean? Any Koreans in the audience? No? Okay. Anyway, I've heard that it's really great. I'm suspicious. I'm a little suspicious there are no Koreans in the audience. Oh yeah, is it true? Is Korean really great? I don't want to put you on the spot. Yes? Okay. What message here is, well, yes. I mean, it's not that surprising. You know, a script that's engineered might be better than a script that's just sort of randomly patched together. Now, let me show you sort of some of that. Oh, first, let me just draw an analogy to the keyboard. So we all know our QWERTY keyboard, the one that we usually use, is inspired by the typewriter and has a history. It's actually pretty, you know, there's a story that it's not optimal, and then this guy Dvorak came along and invented this other keyboard, which is so much better. Turns out that this one is optimized for something, but it turns out only to be about 4% faster in typing. Does anyone here use the Dvorak keyboard? Ah, we do have a Dvorak user. All right, great. So, you know, that means that there are probably million or so, or at least a million users in the world if we had one. So that's pretty good, you know. But still, it's not that well often used. On the other hand, there's this thing called shape writing, or people use swipe and all kinds of variants. And actually, Microsoft recently, you know, their mobile phone has, like, it uses machine learning, right? So their machine learning is the best, I guess, around. And they set the Guinness Book of World Records for the fastest typing on the phone using this swipe. And it uses, or shape writing, it uses machine learning. And now, how many people here use this? Anyone here use this kind of writing system? Yeah, we have more. I'm getting a sense that not everyone is into raising their hand. But anyway, I think there might be 100 million users or more for this technology. What is the message? So you should go for a big win, of course. If you have a small win, people may not do it. And of course, it's also good to be easy to learn. Actually, let me see. Okay, first question. How many people are here? Okay, good. Okay, good. All right. So, okay, now let me ask. If this keyboard were, let's say, twice as fast as the QWERTY keyboard, how many people here would go through the trouble to learn it? Depends, but you can kind of guess. I mean, you'd have to make your own guess. It depends. But I got a lot of hands at it. You can't see, but like maybe more than half. So what that tells me, which is kind of interesting, and I'm very interested to see that, I was curious, is that actually the failure of the Dvorak keyboard is not because it was so hard to learn. It's because it didn't give you that 2x speed up, right? I mean, sure, it takes a long time to learn, and that's a big barrier. But actually, even worse is the failure to be a big win, right? If it were twice as fast, you know, you guys are rational people. We spend a lot of time typing. It makes sense, yeah. If it took me a week to get up to speed, or even longer, it still might be a big win over the years. Okay, good. So, okay, so what do we have that you know our ancestors didn't have? We have a lot of things. We have precision. Our computer display or even a laser printer can print out things at very high resolution, potentially. We have color. If you want to use it or not, it's up to you. We have animation, potentially. These are things that you would like the language to be readable without them, but they can add redundancy to make it even more readable. Animation can be very upsetting, but it can also be, if it's done nice, it might be possibly subtle and good. Interaction. So how would you use an interaction? Well, maybe the script is fairly clear for almost all the words, but when it's not clear, you could zoom in, or you could somehow click on something to make it more clear. We have big data, wow. Presumably people didn't have so much of that in the past. We have crowdsourcing, we have psycholinguistics. We have so many things. But most important, I think, is that we have the ability to create these apps and plugins so that people can communicate with one another in a new script that in the past you wouldn't have been able to do, right? If I had invented a new script 100 years ago, it would be like good for you, and you can write notes to yourself. And actually, people did. Leonardo da Vinci had his own thing, and J.R. Tolkien created a script. People learned them, but it wasn't very popular. Okay, let's talk a little bit about, this is like an oversimplified model of learning. Wow. You guys are fast. I just gave this talk in Israel, and it took a long time. But anyway, so a lot of people here raise their hand. So it says, please raise your hand if you could read this sentence. Very good. And how are you doing that? It turns out a lot of it is from the shape of the word. And it turns out it's harder to read a sentence if the words are not shaped like you're used to. And that's kind of an oversimplification. But even look at the text here that I took from this picture. I mean, we're all used to seeing this kind of annoying text, trying to understand, and things are blurry, and what is this, and make it out. And what you see are the shapes of these words. So let's look at this simplified model of reading for a second and see how good is English right now. So you could look at the shape of words and say, okay, there's some words that are letters that are tall ascenders, and there's some like down here, and there's some letters that are descenders that go below the line, and then there's the neutral letters that are just in the middle. And so if you just take a pattern, say, okay, 3 neutral letters, well, there's so many words: was, can, are, now. Take a pattern like that. Okay, can anyone think of a word that fits that pattern? What? Any words? What? P, right? Go ahead. I mean, I'll wait. You got to do it. Okay, anything else? What? You? Good, that's the most likely word according to my database that had it, but P is on your mind. Anything else?
Yes.
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 Gun, okay. Anyway, yes, they continue. So these are the words. And what about this? I don't think there are any. I mean, there's, what? Hmm? 2 low words and then a tall one. I can think of a file format that fits this that I'm using right now. But that, yeah, PowerPoint. But that wasn't in the database because it was of movie subtitles. Anyway, so nothing, really. There's almost nothing in that of that shape. Too bad. Okay, so let's think about what you want from a language, maybe. A simple model would be to say, okay, let's say we picked a word from our dictionary and then then looked at its shape. So we picked a word distributed like English, and then looked at its shape and then said, okay, if we just saw the shape and guessed what's the most likely word, how often would we be right, or how often would we be wrong? So let's say our ambiguity is how often we'd be wrong. So you pick a random word from the dictionary and they say, okay, I think take your best guess, just according to the distribution words that fit that shape, and say, okay, well, how often am I right? So the error is these. You'd get it right for you, you'd get it right for was, you'd get it wrong for all these. What's your error? It's pretty easy to figure out. For English, it's about half. So half the time you'd be right, just from the shape, which is kind of interesting. And then you can do a little ideal experiment. So if you want to improve it, let's just swap 2 letters, O and Q. Let's write every O as a Q and every Q as an O. Okay, what do I mean here? Here's what I mean. Can you read this? You can still read it. Okay, so what happens is, this U and yes no longer collide. So we're getting yes right, okay? And we're no longer getting yes wrong. And we're no longer getting all these, there were tons of words in this category because most letters are neutral. So a lot of them go on. And now there's a word here which is get. No, actually got. So got and get have now new shapes. So you're doing much better, and you get 10% decrease already in the error. So I'm saying this not because I think this is the most realistic model of reading, but shows you that English is probably not optimized, right? I mean, it's coming from some kind of ancient antiquity. And you might say, well, wow, how did we get 50% accuracy just from the shape? Well, it's probably many of you know this, Zipf's law or something, that much of the distribution is coming from a small number of words, right? So just to drive this point home, I mean, you might say, well, here's a simple improvement you could make to English. And this is not the most radical, or I don't know if we want to, but just to show you that it's not optimal. So let's take this text, which is from Hemingway. Okay, and let's say, these darn capital letters, let's get rid of the capital letters. Let's just do something else with them and keep them somehow lowercase, maybe make them bold or underline or something. Okay, because if you're a newcomer to English, you have to learn 26 lowercase and 26 capital. Why? Okay, so now we only have 26 letters, so we got rid of 26. Let's add 2 more letters into the language. Let's add a letter for the word the. Okay, I'll make it a theta. Why not? And then let's add a word for and, which I'll make as an ampersand. Okay. So you could try reading this in the late summer of that year. We live in the house across the river and the plain to the mountains. So you can read it. I mean, you're probably going to be slower reading this than you would be this, but it's also more compact. But I don't know how long it would take you to get faster. I actually suspect you'd be eventually faster at reading this because you can fit more information in your fovea and the little part of your eye that's high resolution, and then you can see more words at once, and your eye does this. They've studied reading amazingly, and your eye does this dance across the page, and the more words you can see in a small area, the faster you go. But anyway, then of course you should switch the O's and the Q's. And then, but my point is there's maybe a lot of room for optimization, so I want people to get excited about this potential problem. And another thing that you see here is that, yeah, I did this in stages, right? I first replaced you could imagine an app that if it's doing this, each day it gives you a new word or something, so you don't have to learn and sit and study for a long time. You already know how to read English. Let's bootstrap off your ability to read English. Let's keep you reading normally, and then, gradually introduce things one at a time. for any approach, not just for this one. Okay, so here's something that's also very exciting, which is that, so you know, I said, okay, in English there were 3 clusters of words, the tall, the medium, and the low. What if you optimize? Okay, so if you optimize and you have only 2 clusters of words, you can match the performance of English just with 2 clusters if you split them up somehow, because all the vowels in English are in the same cluster. If you have 3 clusters, you can do even better. You get down to 30% error. And for the language that I'm going to talk about, this essentially there's binary patterns. There's 7 patterns, not 8, because one of them is all empty. You get down to 2% error. So just from the patterns of which cells are full or not. You know, I mean, in English you sort of break it up into these cells. So you know, we've only used these 3 patterns, but you could use other patterns. You could have all of them. There's 7 patterns that you could use. So if you use all of them, and then you ignore this color distinction, you can get down to 2% error. So that's a big savings compared to 50% error. Sort of just reading the shape. I mean, the inspiration of that one is just, let's just directly read from shape alone. Let's ignore all the other stuff. So, but there's a lot to think about when you want to optimize this, both for ambiguity. So this is not an optimal assignment of the alphabet, because O and U are the same, except you switch red and black. And it doesn't feel right. I mean, the shape alone is not enough then. So, you know, this is a great shape for the word U, let's say. But it's not great in the sense that in many words, O, like, you know, I don't know, if you look at sort of B blank T, or, you know, but, bat, many times the vowels can be interchanged. So you don't want to have O and U looking the same or very similar. So you don't want to just have them be a permutation. You don't have to remember exactly where the red is in order to read this word. You just want to look at the shape and get it. So that's why the 2% figure is nice, because if you optimize the alphabet, you can get it down so that you just look at the shape, and 98% of the time you're right, ignoring the red and black distinction. Let's look at some languages here. So take some languages of the world. In Israel, I learned an interesting fact that apparently, they say that there's a call out from some people who read Arabic saying it's very hard to read and they're looking for a new script. So that might be a great target audience for this if they're actually looking for a new script. But because it's hard to distinguish these subtleties. There's differences between these languages, and you can do things to them. You can make them smaller. And I don't know if anyone can read. Well, you guys probably can't read from back there. But anyway, you can make it bigger again and see how do they look after you make them smaller and then bigger. And some of them lose a lot of form, and some of them maintain more. You can make it really small and then big again. And, you know, of course, this one, almost by design, will keep a lot of its information, at least compared to the other ones. Some of you may know that depending on the program you're using, the way they actually make things small is they use a sub-pixel accuracy and play with the colors of the pixels. I better zoom in. OK, anyway, also blurry. You can look at the blurry performance of things. And I don't know, for me, I'm colorblind. I don't even see the difference between the red and stuff. On my screen, I do, but something here, I don't know, can you guys see any red in there or not? OK, good. So, you know, different people will use different fonts or whatever. It's fine. As I said, so you can optimize it down to the 2% level, and then you get some different assignment. But it may be ugly with words that are, you know, holy. There are lots of holes. And depending on your aesthetic, you may not like it. You may not like the shapes that come out. So really, and what I'm saying is that sort of, in the experiments I do, I just teach people 7 letters on Mechanical Turk because it's easier to learn an alphabet with 7 letters. You make tons of words. And you know, if you assign one assignment of the letters, you'll have very blocky letters here, and another one you'll have letters with holes in them. So really, you have to figure out something that's both aesthetic and unambiguous. And so if you ask people, you know, what shapes do you like, I can just go on some crowdsourcing platform and ask people, and they seem to give reasonable answers, I think. And then, which I don't really have time to go into detail, but you can try to learn a model for what people like, right? And you can try to optimize your alphabet for a combination of being unambiguous or clear and, you know, readable in that sense, and aesthetic. I need to do that because I have a terrible sense in design, but maybe a designer could just write a function for what is a nice-looking letter. That would be interesting, too. So I think, you know, you can sort of, you know, I basically, how did I get all those numbers I forgot to mention is I run, I just, for the disambiguity, or the ambiguity number, I just run a simulated annealing algorithm. It kind of blows right through the 26 letters. And so here you can also, you know, you're just looking for a permutation. So here you can do the same to try to optimize it. And, you know, people seem to prefer red, but you could, you know, put in your own preferences and say, oh, I don't want to have too many holes. I don't want to have this, and whatever. You can design your own alphabet however you like. So I did experiments where I would show people words, and then I would ask them whether they like them. I would also ask them if they have seen that word in the past as like a control to see whether they're paying attention or not. And it was actually fun, and that data could be useful too, and as we saw in the last talk. And then you generated features for these things and tried to fit the data. And anyway, I'm not convinced that I have the best results yet, but I think there's a lot of room for generating nice alphabets. Last thing I want to mention is that there's been a lot of work on input systems, and of course it's natural. That's a pain point that you all feel, right? Because you're fast at typing on the computer, slow at typing on your phone, so you feel like, I wish I could type faster. You don't feel any pain with reading, but maybe there's still a room for improvement. But the ideal, I mean, when you think 20 years down the line, you know, or 100 years, as long as, let's say we're not, you know, communicating by telepathy, then probably you would hope that we have some kind of input system and reading system which are nicely coordinated. When you used to write with a pen, it was very naturally connected to the way you read. You wrote the shape. Now when you type, it's third from the left button in the middle. It gives you this shape. And there's some kind of disconnect, I feel. And it would be neat to have an input system which is much more efficient and coordinated with the output system. And like, you know, there's this old idea of the chorded keyboard where you type, you know, multiple fingers at a time. That, for example, would pair nicely with this dot script. The other inputs may pair nicely with other visualizations. So down the line, I think it'd be neat to think of a combination. So basically, you know, the doors are open to any kind of wacky ideas people have for different letters. And you know, I've talked about the different things you have to optimize, which are sort of you want it to be readable, not ambiguous, quickly readable, and you want it to be pretty. And I think it's a super fun problem involving machine learning, design, potentially crowdsourcing, and also HCI. Thank you.
Visualize typing. How do you think this would pan out? Like each of those dots with each of the colors, is that how you are visualizing, or are you going to have?
How would you type? The question is, how would you type with these dots? Potentially, I mean, there's this old idea of a chorded keyboard, which goes back many years. And the idea there is you push down fingers simultaneously. So you could have 3 dots, 3 fingers, you know, and you have extra fingers for space or backspace. And you could maybe push down harder for black or red. I'm not, you know, that's not my strength. But you could imagine that you're on the side of your phone. You're actually typing by pushing on the side of your phone. Somebody actually built one of these for regular English. And then you don't have to use up all the screen space for the keyboard. You just, unless you need a special punctuation, you just type away. You can do it in your pocket.
Yeah. I have actually a weird question, maybe along the line with your work. Mathematics is a condensed language, right?
Is it
mathematic notation?
Yeah.
I mean, it's pretty much there where you want to reach. I mean, looking at the formula,
yes.
Here is a lot of meaning that you already can capture with a single gaze.
Yes.
Right. And how do you compare mathematical notation with where you want to go?
How do I compare mathematical notation?
Does it have ambiguity? I mean,
to this project?
Yeah.
Yeah, you could try to design a new script for math. I mean, there's different. I don't know. The thing that comes to mind is LaTeX, right? That's one way of representing a formula, but I don't. Certainly, and yeah. I mean, you could try to design a new script for math. You know, if your computer can translate between this and the old one, I feel like there's a lot of opportunities, and you can also try to help. I think there's probably been some work on helping people who are dyslexic. There's a bunch of areas that you could work on. I feel like there's a big area which is just reading, you know, for normal English, but certainly you could do it in any of the other areas as well. But I'm not sure if I totally got your question.
So I have a question too. So you know, there are these really fast readers. Kind of like super readers. Like my sister one. Like you know, she read a book, and it's amazing how fast she reads the book. Now, is there evidence that the bottleneck is sort of how fast your brain can think about it, or is it just visually how fast you can take in a page?
Right.
Do these compare between, say, readers in different languages?
Yes.
Maps reading different?
There have been studies sort of where they found that the bottleneck was actually the processing for some people of just the processing. It wasn't the reading. But so in that sense, I'm personally a little more interested in the question of fitting more and in a smaller space comfortably than in increase the max reading. It may. I mean, I don't know. I don't. Or maybe for some people it would, and for others wouldn't, right? Maybe some people are already at their peak speed. But maybe for your sister, right? You know, she would be able to fly. Yes, and there may be different alphabets or different scripts that work better for some people than others. That's a super interesting. And as far as I know, it hasn't totally been worked out, which is kind of weird.
I can't remember the name of it. Maybe someone else knows, but I recently saw a website that was advertising the idea that
Spritz.
Yeah, right.
Okay.
So could you imagine the shapes and
Yes.
allowing that to work even faster?
Yeah. Let me just put up
I mean,
the.
it seems like it should.
Yeah.
If you become fluent in the language. My second question is, how fluent are you in any of these more
Oh
exotic?
yeah. So Spritz is this thing. And as a joke, I put up like, imagine reading your email in this way. So Spritz might be, so Spritz is, you guys can read that. And imagine trying to read your email, which would be painful because you don't want to read your email linearly. You want to scan through your email. You don't want to read it. But it might be good for reading a book on your watch. Anyway, yes, I don't know. I mean, it could be. It's super interesting, and when you delve into the science of reading, it's super interesting to see how they do it and how the eye works. But the eye may read differently. These weird blocky shapes, the eye may read them a little differently than it reads the other letters. So people have done a lot of work how eyes read certain languages, and they've done a lot of local optimization. Oh, I should finish. Local optimization on the letters. A lot of optimization, making them beautiful. But like this other stuff, I don't know. It's a good question how animation would help. I don't know. Almost like Morse code.
Let's do one more question.
When you design the letters, you are using red color and black color together. But if I write it on the paper, it's very hard to get color into it.
Yes.
Why do you need to color it?
You don't have to. It was just an example of using some technology. You could do it all with black. I mean, you could have some system where, I don't know, if I write it with a circle and an X and an O or something. X means red and O means, you see what I mean? I could translate it to different shapes or something, which you might want to do anyway to add redundancy so that you could, exactly for that reason, so that you could write it on paper nicely. So that's a good point, that you might want something which is easy to write on paper. I think also you want something which is easy to type. But my first priority, I'm not thinking of this as replacing English by any means, so probably people will write regular English. Is just for those small fraction of users who are interested in reading faster and learn this alternate script, then they can also read faster. But, yeah.
Thanks to the speaker again.
Thanks.